Good morning students, welcome back to chemistry class. Today we are going to study about chemical properties of water. Chemical properties of water in first volume, page number 107, chemical properties of water. In this session we are going to study about the reaction of water with alkali metals, alkaline earth metal, transition metals, halogens, and compounds of nonmetals, and amphoteric nature of water, and the covalent nature of water, and the coordinate covalent, how to form coordinate covalent complex. That's all today we are going to study. Okay. First upon, reaction with alkali metals. Water reaction with alkali metals. What are the alkali metals? You know what do you mean by alkali metals? Group 1 elements we call as the alkali metals. What are the group 1 elements? Lithium, sodium, potassium, rubidium, cesium, francium. These are called the group 1 elements. Okay. So here when water reacts with group 1 elements, that is alkali metals, to liberate hydrogen gas and form alkali solution. Okay, so for example, I am taking one of the example, sodium. You know sodium, what is the symbol for sodium? Na. Na, when reacts with water molecule to liberate hydrogen gas and it form the alkali solution. Okay, so here when a sodium atom, sodium means one of the metal, when it combines with the hydrogen water. Okay, water when adding water with the sodium metals, the reaction it is suddenly takes place. Okay, a reaction it is suddenly takes place and the hydrogen gas suddenly liberates. Okay, so you know how water means H2O. When we are adding water molecules with the metals, so it decomposes to form hydrogen and H plus ions and OH minus ions. Okay, so two atoms of H plus ions combining to form the hydrogen gas, and hydrogen gas is evolved, and the OH minus are present in water molecule. It combines with the sodium atom to form sodium hydroxide solution. Sodium hydroxide solution, NaOH solution. These are about the reaction with alkali metals. Okay, the first reaction. And second upon, a reaction with alkaline earth metals, that is group 2 metals. Group 2 metals we called as the alkaline earth metals. Okay, what are the group 2 metals? You know about the group 2 metals. What are the group 2 metals? Beryllium, calcium, magnesium, strontium, barium, and radium. Okay, beryllium, magnesium, calcium, strontium, barium, and radium. These are called the group 2 elements. So here when water combining with the group 2 elements, that is alkaline earth metal, except beryllium. Beryllium is the first element in second group. So except beryllium, all the other metals, alkaline earth metals, are reacts with hydrogen like alkali metals. Okay, but less violently. Less violently means when water combines with alkali metals, the reaction suddenly takes place and suddenly hydrogen gas is evolved. But in the alkaline earth metals, the reaction is slowly done. Okay, the hydroxides are less soluble than those of group 1. Here when group 1 element means sodium, when sodium combines with the water molecule to form sodium hydroxide, the sodium hydroxide well dissolved with water. Okay, well dissolved in water. But group 2 elements, barium except beryllium, barium, magnesium, calcium, these elements, it is sparingly soluble with water, less soluble with water. Okay, so the reaction is slowly done. Okay, so when, for example, barium, I'm taking one of the example, barium, Ba means barium when combines with water to form barium hydroxide, BaOH twice. Okay, you know when water molecule added with the metals, the hydrogen water molecule decomposed to form H plus and OH minus ions. The OH minus ion, it combines with the metals to form these metal hydroxides. Okay, metal hydroxides, that is alkali solutions. Okay, and hydrogen ions combine to form the hydrogen gas. It liberates hydrogen gas. Okay, this is the second reaction. Okay, and third one, the reaction with transition metal. Reaction with transition metals. Okay, some transition metals react with hot water or steam to form a corresponding oxides. Okay, some transition metals, the transition metal, it is less react with the water. Okay, less react. For example, iron. We are taking one of the example, iron. When we are taking one of the iron rod or any iron material, when we are adding water with the iron material, no reaction takes place there. Okay, no reaction takes place there. But this iron is one of the transition metal, you know. Iron, lead, copper, the gold, silver, these all the transition metals. Okay, transition metals are low reactive, less reactive elements. When comparing alkali metals and alkaline earth metals and non-metal, transition metals are slowly react with the water molecule, less react with the water molecule. Okay, for example, we are taking iron. Iron, it is one of the transition metal. When we are adding water with iron rod or any iron material, no reaction takes place there. But when hot water, okay, when hot water or steam means water vapor. Okay, steam. When hot water or steam is passed over a red hot iron. Okay, iron, when it is normal condition, it does not react with water, hot water or any water. But when iron, it is in red hot condition. Okay, when iron is heated with a red hot condition, that condition, when we are adding steam or hot water, it forms the iron oxide and with liberate the hydrogen gas. Okay, when iron, it is in red hot, when heated the iron with red hot condition, and the red hot condition, when we are adding the steam or hot water, it forms the iron oxide, that is ferric oxide, and the hydrogen gas is also liberates there. Okay, so when iron, what is the symbol for iron? Fe. Fe, symbol for iron what? Fe plus water. What is the formula for water? H2O. When iron, when Fe it combines with the H2O, it forms iron oxide. What is the formula for iron oxide? Fe3O4. Fe3O4. Okay, this is ferrous oxide. Fe3O4, it is the ferrous oxide, and it liberates the hydrogen gas. It liberates the hydrogen gas. Okay. Okay, these are about the reaction with transition metals. Okay, now we are going to balancing these three equations. First upon sodium. When sodium combines with the water to form sodium hydroxide and hydrogen alkali metals. Okay, when react with alkaline earth metal, that is second group elements, barium, when combines with the water to form barium hydroxide and liberate hydrogen gas, and also iron react with the water to form iron oxide and hydrogen gas is liberated. Okay, here first reaction, when we are balanced the first reaction here, sodium 1, sodium the reactant side, here sodium only 1 sodium, here also only 1 sodium. Okay, but hydrogen here, the reactant side hydrogen, 2 hydrogen is there, but in the product side hydrogen, how many hydrogens are there? 2 plus 1, 3 hydrogen is there. Okay, 3 hydrogen atom. So we have to make here the reactant side, we make 2. Okay, 2 means totally 4 hydrogen is here. Okay, but here only 3 hydrogen. So we have to make here 2 sodium hydroxide. So but here oxygen, here 2 oxygen, here also 2 oxygen, now balanced. Okay, but sodium here 2 sodium, but here only 1 sodium, so we have to make here 2. Now equation is balanced. Okay, how many sodium atom? 2 sodium atom, here also 2 sodium atoms, and hydrogen 2 2 are 4 hydrogen, here also 2 plus 2 4 hydrogen, oxygen 2 oxygen, here also 2 oxygen, equation is balanced. Here barium, when alkali earth metal, there is second group metals, barium, here only 1 barium, here also only 1 barium, hydrogen here 2 hydrogen, here 2 plus 2 4 hydrogen atoms here, so we have to make here 2. Now equation is balanced. Oxygen also balanced now, here 2 oxygen, here also 2 oxygen. Understood? Equation is balanced. And what is the third equation? When water reacts with the transition metal, what is the product we get? Iron oxide, Fe3O4. Fe3O4. Okay, Fe3O4. So when balanced the equation here, iron, in the reactant side only 1 iron, but product side 3 iron. So we have to make here 3 Fe. Okay, now hydrogen, here only 2 hydrogen is here, here also 2 hydrogen, but oxygen here 4 oxygen, so we have to make here 4, because here product side 4 oxygen is there, reactant side only 1 oxygen, so we have to make here 4. Now equation is balanced, oxygen is balanced. Okay, but hydrogen here, how many hydrogens is there? For 2 are 8 hydrogen, but here only 2 hydrogen, so we have to make here 4. For 2 are 8. Now equation is balanced. Okay, these are the reaction with alkali metal, alkaline earth metal, and a transition metal. Okay, and another transition metal, for example lead and copper, it decompose water at white heat. White heat means, what do you mean by white heat? White heat means it is very high temperature. Okay, it is high temperature than the red hot condition. Red hot heat means temperature is 900 to 900 degrees Celsius to 1000 degrees Celsius, but white heat means very high temperature, above 1200 degrees Celsius. Okay, that is called as white heat. Okay, so water only reacts lead and copper when it decompose only white heat. Up to high temperature only copper and lead decomposed with the water. Understood? And silver, gold, mercury and platinum do not have any effect on water and the elemental form. Okay, understood? Silver means silver, it not react with water. Gold also not react with water. Mercury also. Okay, but in the elemental form means, what do you mean by elemental form? The carbon, C, carbon, sulfur, yes, phosphorus, P. This is the elemental form. In the elemental form, non-metal do not react with water. Okay, a non-metal, in the elemental form, non-metal do not react with water. Okay, but already we studied about that. When elemental form of carbon when it is in red hot condition, high temperature, when it react with oxygen water molecule to form carbon monoxide and hydrogen, that is called water gas. We studied already. Preparation of hydrogen chapter we studied. When preparation of hydrogen chapter when carbon at 1000 degrees Celsius, high temperature, okay, high temperature 1000 degrees Celsius, there is white heat temperature. When coke, there is carbon in an elemental form. Carbon when react with water, there is steam, we get the carbon monoxide and hydrogen, that is water gas. Okay, these are about the reaction with water, reaction of water with alkali metal, alkaline earth metal and transition metals. Okay, and then we are going to study about reaction of water, that is chemical property of water with halogens. Chemical property of water, chemical properties of water with halogens. Okay, when halogens react with water to give an acidic solution. Okay, when halogens react with water to give an acidic solution. Halogen means, what are the halogens are there? Group 17 elements we called as halogens. Okay, group 17 elements we called as halogens. Okay, what are the group 17 elements? Can you tell group 17 elements? Fluorine, chlorine, bromine, iodine. These are called the halogen, group 17 elements. Otherwise, we call this halogen family. Here, when water, it reacts with halogen to form their respective acids. Okay, acids. For example, I am taking chlorine, one of the halogen, that is chlorine, Cl2. Cl2, when it reacts with water, what is the formula for water? H2O. When halogen combines with the water, that is chlorine combines with the water, the hydrogen from the chlorine, one hydrogen in water. Okay, we know hydrogen water molecule when we are adding any metals or non-metals, water molecule decompose to form H plus and OH minus ion. Okay, so hydrogen H plus ion in water, it combines with the one molecule, one atom of chlorine. One atom of chlorine from the chlorine molecule to form hydrogen chloride, that is hydrochloric acid. And the OH minus, it combined with the another one chlorine. Here Cl2 means how many chlorine atom having? 2 chlorine atoms. Okay, so one chlorine combines with the H plus to form hydrogen chloride, hydrochloric acid, and another one chlorine combines with the OH minus to form HOCl. To form HOCl. What is the name? Hypochlorous acid. Hypochlorous acid. Okay, so water when combines with the chlorine to form hydrochloric acids and hypochloric acids to form their corresponding acids. Understood? This is one of the example. And another one example I am taking, another one example, halogen, another one halogen, fluorine, F2. Okay, when fluorine, it differently reacts with water when comparing the chlorine. When chlorine react with water, when we are adding chlorine with water, it forms acids. Okay, hydrochloric acid and hypochloric acid. Okay, hypochlorous acid, hydrochloric acid and hypochlorous acid. But here, when fluorine, fluorine, it combines with water, it reacts differently to liberate oxygen. To liberate oxygen gas from the water. Okay, so here fluorine F2 when combines with the water to form hydrogen fluoride. Hydrogen fluoride. hydrofluoric acid, hydrogen fluoride, and the oxygen from water it liberates as oxygen gas. Okay, when balancing this equation, how many fluorine atom here? 2 fluorine atom, but here only 1 fluorine. So we have to make here 2. Here hydrogen, how many hydrogens having? 2 hydrogen, here also 2 hydrogen now. Oxygen, here how many oxygen having? Oxygen gas means oxygen does not exist in free state. Oh, atomic state does not exist. So it exists in molecular form. That is oxygen O2, diatomic molecule O2. Okay, see here 2 oxygen atoms are having, so we have to make here 2. 2 oxygen means how many hydrogen now? 2 2s are 4 hydrogen. Okay, so we have to make here 4 hydrogen fluoride. 4 hydrogen fluoride means fluorine also here 4, but here only 2 fluorine having, so we have to make here 2. So now 2 2s are 4. Fluorine here 4 fluorine, hydrogen 2 2s are 4, here also 4, oxygen here 2, here also 2. Understood? Okay, and then we are going to study about when water combining compounds of non-metal. When water combining the compounds of non-metal to give acidic or alkaline solution. Okay, both acidic or alkaline solutions when water combining with compounds of non-metal. Okay, I am taking here compounds of non-metal. I am taking one of the example, CO3 2 minus. Okay, CO3 2 minus, one of the example compounds of non-metal. Okay, carbon one of the non-metal, and oxygen also another one non-metal. So 2 non-metals, that is the compound of non-metal, CO3 2 minus. CO3 2 minus, when it combines with the water to form bicarbonate. Okay, alkaline solution, bicarbonate, and OH minus. Okay, OH minus ions. This is one of the ions only we are taking here, but for example, carbonate CO3 2 minus plus water to form H. Okay, you know water, it decomposes to form H plus and OH minus ion. So H plus ion combining with the CO3 2 minus to form bicarbonate ions, and OH minus ions separately decompose. Okay. So it is only ionic form only, simple form only we are taking here. But carbonate means maybe sodium carbonate. Okay, maybe sodium carbonate, maybe magnesium carbonate, maybe calcium carbonate. Okay, any carbonate salt, any salt when we are adding with water to form bicarbonates. And liberates the alkali. Bicarbonate means one of the alkali, and OH minus, this is another one of the alkali. These two not acids. Both two are the alkali solution we obtained. Then we are going to study about very, very important things, that is water is an amphoteric oxide. Water is an amphoteric oxide. What do you mean by amphoteric? Amphoteric means two. Okay, both water acts as acid or base. The water can act both as acid or base. Okay, we will study about that. Before that, you should know about what is acid, what is base. Okay, many explanation, many definitions are having about acid and base, but here what is acid, what is base? Here we are uh, going to study the protonic concept given by Lowry Bronsted, one of the scientists. Lowry Bronsted given by protonic concept about acid and base. Okay, according to Lowry Bronsted theory, what do you mean by acid? Acid means the substance which can accept proton. The substance which can accept proton, that is called acid. And base means the substance which can donate proton. Understood? This is the definitions of acid and base according to Lowry Bronsted, that is protonic concept. Okay, here what do you mean by proton? Proton means H plus. Okay, because when water decomposes to form H plus and OH minus. Okay, here water, hydrogen atomic number 1, only 1 electrons are there and only 1 protons are there. Okay, when hydrogen, it lost this 1 electron, it give this 1 electron to the OH minus ion, OH ions, so it becomes H plus. Okay, H plus means here no electrons, only proton, only 1 proton is there. So we can tell about this is H plus means proton. Only 1 proton is there, so we telling like this proton. H plus means proton. Okay, so what do you mean by acid? According to Lowry Bronsted theory, acid means substance which can accept proton. Base means substance which can donate proton. Okay, here we are studying about the amphoteric nature of water. Okay, amphoteric nature of water. Amphoteric means the water has two nature. What is the two nature? Acidic nature and basic nature. Water can access both acidic and basic nature. Okay, for example, here when NH3, ammonia, when ammonia, it reacts with water to form ammonium ion, NH4 plus OH minus ions. Okay, ammonia NH3, when it combines with water to form NH4 plus OH minus ion. Here water, water, how can you decompose water? H plus and OH minus ion. H plus and OH minus. Okay, this H plus ion, here this water molecule, it donates its proton to this ammonia. Okay, donate this proton to ammonia, so it becomes NH4 plus, H plus. Okay, so here the water acts as base. Water acts as base because it donates a proton to the ammonia molecule to becomes NH4 ammonium ion. Okay, understand? Like that. Another one example I am taking hydrochloric acid. When hydrochloric acid dissolved with water to form, here also water we can decompose with H plus and OH minus ion. Water decompose to H plus and OH minus ion when it dissolved in hydrochloric acid. Here the water, okay, already water means H2O. So here H plus and OH minus ion having. The hydrochloric acid decomposed to, when dissolving with water, it can it decomposed to H plus and Cl minus ion. Okay, so these H plus ion, the hydrochloric acid donate this proton to this water molecule. Understood? So water becomes H3O plus. H3O plus. Here H2 already having, so one proton donate, the hydrochloric acid donate its proton to the water molecule. Okay, so here water accept the proton. The water accept the proton to form H3O plus Cl minus ion. Okay, so hydrochloric acid only donate H plus ion. So hydrogen leave its electron here. Okay, and H plus ion only go to the mixed with the water molecule to form H3O plus. Here water accept the proton. Okay, accept the proton. So in this reaction water acts as acid because it accepts proton. Okay, but here when ammonia combines with water to form ammonium ion and OH minus ion, here water acts as base because it donate proton. Okay, for the reaction of hydrochloric acid with water, here water accept the proton. So here water acts as the acid. So when a substance donate proton means that is base. When a substance accept proton means that is acid. Okay, so now we clear the water is an amphoteric acid. Okay, amphoteric oxide. Understood? I think all of you understood. And this is the one chemical property. And another one chemical property of water means water dissolves ionic compounds. You know, ionic compound means when sodium chloride when combines with water to form NaOH and HCl. Okay, NaOH and HCl. Okay, this is the ionic compound. NaCl is the ionic compound. Like that, the water also hydrolyze some covalent compounds. Which covalent compound? Here, two examples are there. First one, silicon tetrachloride, SiCl4. Okay, this reaction is the covalent, the water reacts with covalent compound. Okay, so the hydrolyzed with the covalent compound, SiCl4 means silicon tetrachloride. When it combines with water to form silicon dioxide or silica plus HCl. Okay, so here we have to balance the equation. Silicon here only one silicon, here also only one silicon. Chlorine here 4 chlorine having, but here only one chlorine. So we have to make here 4 HCl. Okay, now we have to balance the hydrogen. Hydrogen here 2 hydrogen, but here 4 hydrogen. So we have to make here 2. Okay, so 2 2s are 4 hydrogen. And also oxygen, here 2 oxygen, here also 2 oxygen. Equation is balanced. Okay, so this reaction, what is the chemical property? The water molecule, water can hydrolyze covalent compound also. Okay, and another example, the phosphorus pentoxide, P4O10. Okay, this actually P2O5. When we are multiplying with 2, we get the P4O10. Okay, phosphorus pentoxide, when it hydrolyzed. Okay, phosphorus pentoxide, 2 molecules we are taking. So when it hydrolyzed to form phosphoric acid. What is the formula for phosphoric acid? H3PO4. Phosphoric acid, what is the formula? H3PO4. When phosphorus pentoxide, when it hydrolyzed to the water, we get phosphoric acid. Okay, hydrolyzed. Okay, understood? So here we have to balance the equation. Phosphorus here 4 phosphorus having, but here only one phosphorus, so I have to make here 4. Okay, remember, you should remember what is the formula for phosphoric acid. H3PO4. H3PO4. When phosphorus pentoxide, 2 molecules of phosphorus pentoxide mixed with water, we get phosphoric acid. Silicon tetrachloride, when mixed with water, we get silica and HCl. Silica, what is the formula? Silica or silicon dioxide. What is the formula? SiO2. SiO2. Okay, when phosphorus pentoxide combining with water, we get phosphoric acid. Okay, so here the phosphorus is balanced now, and oxygen, how many oxygen here? 10 oxygen, but here 10 plus 1, 11 oxygen having, but here 4, so 16 oxygen having. So remaining here only 11, but here, sorry, here hydrogen, the oxygen here 10 plus 1, 11, but here 4, 4, 16 oxygen are having. Okay, so here we have to make here 6. Okay, 6. So here 16 oxygen, here also 4, 4, 16 oxygen. Okay, and hydrogen here 4, 3 are 12 oxygen, 4, 3 are 12 oxygen, here also 6, 2 are 12 hydrogen. Okay, 4, 3 are 12 hydrogen, here also 6, 2 are 12 hydrogen. Equation is balanced now. Okay, this is the another one chemical property. The water can hydrolyze to some covalent compound also. And another next chemical property, the water, the form coordinate covalent bond. The water can form the coordinate bond. Okay, water, the water can form coordinate bond. Coordinate bond. Okay, coordinate bond with the central metal ion or atom. Okay, for example, another example, CrH2O 6 time Cl3. Okay, this is one of the complex. Okay, this is one of the coordination chemistry, coordinate complex. Okay, so here how many water molecules are there? Totally 6 water molecules are there. Okay, the 6 water molecules, this chromium, it is the central metal atom. In 12th standard you will study clearly about that. Coordination chemistry, in coordination chemistry lesson you will study clearly. Okay, so here you should understand the water can form coordinate covalent bond with the central metal atom. Okay, here what is the name of this compound? How many water molecules? 6 water molecules are there. What is the name? Hexa. 6 means hexa aqua. Water, when we are what is one of the ligand, when we are writing the name of this compound, coordination compound, hexa aqua, and what is the central metal ion? Chromium and trichloride. Okay, this is the name, hexa aqua chromium trichloride. Okay, here this 6 water molecule can form 6 coordinate covalent bond. Okay, 6 coordinate covalent bond with the chromium atom. Understood? What do you mean by coordinate covalent bond? Coordinate covalent bond means the bond formed between the two atoms by the sharing of pair of electrons, but here the sharing, the shared pair of electrons given by only one atom. Okay, for example, here the 6 water molecule when bonding with the chromium atom, here the water molecule only give the pair of electrons to the chromium atom. Okay, this is about the coordinate covalent bond. Another one example, barium chloride 2H2O. Okay, diaqua barium chloride. Here also the water the water molecule are present in the interstitial position. Here, the water molecule present in the interstitial position. Interstitial position means when barium atom, it combines with the 2 chlorine atom, and these 2 water molecule present at the interstitial compound. Okay, interstitial compound, it is not in correct position of this. Okay, but it is in separate position. That is the interstitial position. Okay, the when it is sitting in the interstitial position, it can bonded with the other molecule by the hydrogen bonding. This is called the interstitial position. Okay, understood? And so this is the chemical property of water. Okay, so the property of water means when the water molecule can form the coordinate covalent bond with the central metal atom in a coordination complex. Okay, in a coordination complex. Another one example given, the copper sulfate pentahydrate. Copper sulfate pentahydrate. Here we can know clearly about the coordinate covalent bond with the complex. Okay, copper sulfate pentahydrate. From here, the copper sulfate pentahydrate, we can write another one form. Okay, this is the isomeric form. This is we can write in the complex form. The copper H2O 4 times sulfate H2O. Okay, here in this compound, the 4 water molecules form coordinate bond. These 4 water molecules form coordinate bonds with the copper. Okay, while the other another one, 5th water molecule, the 5th water molecule present outside the coordination. Outside, this is the coordinate complex. Okay, the 4 water molecule can form coordinate covalent bond with the central metal atom copper, but 5th water molecule is present outside the coordinate complex. Okay, outside the coordination can form intermolecular hydrogen bond with another molecule. This 5th water molecule can form intermolecular hydrogen bond with another one molecule. It can form the intermolecular hydrogen bonding. Okay, for example, how can you write? What is the name of this compound? This is the ligand. Water here. This is in coordination complex. So we can write this water molecule. We can write tetra. How many water molecules is present inside the coordination? 4 water molecules. So we can write tetra, and water means aqua. Okay, tetra aqua. Copper, tetra aqua, copper. 2 sulfate, 2 this oxidation number, 2 sulfate, tetra aqua, copper, 2 sulfate monohydrate. Copper 2 sulfate monohydrate. This is the name of this complex. How can you write this structure? How can you understand the water molecule form the coordinate bond? Here the copper, it is the central metal ion. So copper we can write at the center, and the 4 water molecule we can write. These 4 water molecule can form coordinate bond with the copper. Okay, central metal atom. This is one of the oxygen. Okay, this is the 4 water molecule. These 4 water molecule forms coordinate bond with the copper. Okay, and another one water molecule present outside the coordinate. Okay, and here one of the sulfur molecule also having okay. and this water molecule, this water, it forms the intermolecular hydrogen bonding. It from this is the hydrogen intermolecular hydrogen bonding with another one molecule, another one molecule. Okay, another one sulfate. Okay, another one sulfate. Understood? These are about the structure of copper sulfate pentahydrate complex structure. Okay, so what is the chemical property of water? Water molecule can form coordinate bond with central metal atom. Okay, so today how many chemical properties we studied? First upon, the water molecule can react with the alkali metals, alkaline earth metal and transition metal, halogens and non-metal compounds of non-metal, and we studied about the amphoteric nature of water, and how it hydrolyzes the covalent compounds and how it forms the coordinate covalent bond. That's all we studied today. Okay, students, today our assignment, explain the amphoteric nature of water. Explain the amphoteric nature of water. If you have a book, take your book now. Okay, students, take page number 108. In your book, page number 108. Explain the amphoteric nature of water. Page number 108. Water is an amphoteric oxide. It has the ability to accept as well as donate proton, and hence it can act as an acid or a base. For example, in the reaction with HCl, it accepts proton, whereas in the reaction with weak base ammonia, it donates proton. NH3 plus H2O gives NH4 plus OH minus, HCl plus H2O gives H3O plus Cl minus. Okay, students, you should study and write the assignment and send me through my WhatsApp number. Okay, thank you.